Hello, friends. If you're watching this live, you're streaming wrong. You should be in this build stream. You should not watch us. If you're really interested in what we are doing, you can still watch the recording. But if you really insist and you want to ask questions during the review, you're welcome to stay. But consider to watch the build stream instead. They are probably more entertaining than we are. All right, so let's go. We just go left to right, or do you want to go to the 10 one that you posted in chat, Tanner?
Go from top to bottom with that.
Let me see because you in the in. Zoom. Let's just. Alrighty, so
Cannot see
cannot see the screen. I thought I shared the screen. Oh, I didn't do it with Teams. Teams. Now I have to figure out how to do this in Teams. Where's my sharing tray? Here's my sharing. And not select. Oh, that's right. I maximize Teams again, and sometimes when you do that, it stops sharing the screen, which is the most bullshit thing ever. But there we go. Can you still? I hope you can still share the. I hope you can still see the screen.
No, I can.
Perfect. Do this then.
So we live now.
We are live, and take it away.
This first set of APIs, set of APIs, they load a scalar and replicate it to every element of the vector. For x86, these are called broadcast scalar. Their size. Um, we're matching the underlying naming in terms used by ARM here, so it's loaded replicate. And then of course it just the underlying primitive type, the everything except for double long and U-long on both 32 and 64-bit ARM, double long on ARM 64.
So they are all the same.
Yeah, they're all the same, just load and replicate to vector 64 and load and replicate to vector 1. And then for the 10 primitive types, there is no vector 64 version for double long or because those are elements. So there is no replicate.
I assume there's no int better because to understand the bit argument effectively.
We do not support int pointer, int pointer, inint, or inuint for any of the vector types. There is a that we extend to, but that's on the general backlog, and not something today, as it's a much more broadly impacting change.
Broadcast.
Yeah, it just replicates the given value to vector. Replicate is the term used on ARM, and broadcast is on x86. Some platforms that or other.
Is there any instance instead of explicit load, have these just be replicate? They take an aspite and a float, so on.
I mean, in actual.
Yeah, so it could take it by value, and it would just actually load if you call it with an address?
We can do that optimization for the duplicate instruction, but so far for the hardware, and there's been an explicit separate load instruction.
Assuming address is the that we've used for
Yeah, address is the term we've used on x86 and for the existing load and store intrinsic.
APIs of .NET. I can't find anything. They're not in NetBit. Right. So that means I guess nobody has concerns with this API, right? Take silence as approval. Reasons, but hey. Go to the next one.
All right. For this one, we've viewed matching APIs for all so far, but these are the by-selected scalar variants for those APIs that we've. So it's the same API. It's just the last parameter byte indexed which scalar from picking and use it as the rather than doing vector wise.
And they're all the same except some.
And I think the one note variant is when the selected scalar is a vector of double, and therefore there's nothing to select. The name is just multiply by scalar. We differentiate it from multiply-scalar. We operate on the first element of.
Okay, so we're going to have a multiply scalar and multiply by scalar.
Yes, multiply-scalar does left by right 0, where multiply by scalar left 0 through left count times right.
And the instruction there does not take index.
I believe it does, but it can only be because there's only one element vector of double longer U.
What's up with all the commented ones?
The commented ones are ones that we already proved in a separate PR. So, for example, with multiply subtract by selected scalar, the review approved vector 64 by vector 64 version. We did not review by vector 128 version, also supported by the industry.
They're just
Correct.
This is just the like when adding it, you combination types and sizes were
Correct.
already did.
I have a question about the multiply add by scale top section. That has a right index. Would
Correct.
that be named by select, not by?
Yes. Or actually, that one should be I'd have to look at the instruction, but either by scalar and it should have right index and it's vector 64 double, or it should be, or it takes the right index and vector 120 and it should be selected scalar. It's one of those. Likely to copy paste in
I think it should
writing
be
the
by
API.
selected vector 128 double right.
Yeah,
Right,
I think
because
Well, the section below has by subtract by scale kind of match. It has vector 64 double right index.
I actually see, if you look at the second group, that list, that one's by select scalar and it index, whereas the last one is by scalar and it does. The operand list got swapped now. I just fixed it. I don't know if without ammo refill.
That makes sense.
which one should I look for?
That in that very first group under the comments, the entire group, guys. There's that the
This guy
vector
here?
one, no, the one right below it. The fused multiply by add select scalar that turns a double there. That one and the very last end had been their operand. And so I
think I fixed it. Not to well, any other concerns, or is that it?
So I was wondering about some of the down. Looks like there are a lot of names lower down. Let's see. Multiply widening upper and add also take indexes as well, but we don't use the biselected scalar terminology for naming those.
That was likely copy.
I think the last 5 groups biselected.
Yeah, those should be multiply by selected scalar, widening lower and add, I think.
Oh, so but currently set by widening for an add. Multiply by selected scalar, widening.
So
Like, I'm really bad at remembering the sentence when after you spoke it out.
Very long.
So it's multiply. What was that? Multiply by selected scalar, and that should be what instead?
No, that's what it.
Scroll down a little further, right?
A little bit down. More.
Keep going. I think that one. No,
Yeah.
keep. Yeah, there we go.
Which
Multiply
one?
widening.
Yeah, those ones are missing biselected.
The question was, where does the biselect go in that long name? At the end and middle.
Yeah. Yes. The answer is yes.
Question applies to every API that follows that.
Right.
Yes. And so the actual instruction, the multiplication by the selected, and then it's doing a widening, adding.
That would seem to suggest that we should have multiply by selected scalar, widening, and add. That is
Would you like fries?
tall or grande? Right, so then I guess the same is true for multiply, widening, upper, and add then.
For all of the subsequent here, it multiply by selected scalar, and then the rest of the name.
Yes. It's not painful at all. And thank God we have multi-caret editing. Multiply by select scalar widening. Wait, anything else? Like that is oh, this looks perfect. Easier to type. Which was the first group that you?
That looks. You're just missing. No, you fixed the first entry there. You didn't fix the add by scalar.
So these guys here.
One right below it. So the add by scalar. It wasn't both highlighted. It was the last one.
These guys.
No, the one right above that one.
That's this one here.
Yes.
Okay.
Yes.
So then let me. What should that one be? Same as the one above it, or?
Change the vector 128 double to vector 64 double for the right parameter and get rid of the right index.
Yes.
Surprisingly difficult, and every time you hit enter in this text box, it scrolls. It's like not helpful at all. My brain being shitty doesn't. Sorry, what was it? Just tell me again.
Change vector 128 double right, vector 60 double right, and remove.
Yes, it would be 64 of double right, and then remove right index. And other fix we did.
Right.
Multiply by select. Right, and
back, and then versions without adders.
I'm inclined to say this was easy, but that would clearly be all right. So then, next one.
So this is for polynomial multiply. It's split into sections. The first ones are generally available anything advanced sim. They operate light. They're similar to the existing polynomial multiply that we've exposed. They just widen the.
I assume if you're looking for this, you already know what the polynomial does.
Most likely. It's basically bitwise multiplication.
Say that like that would help me. I don't know what bitwise multiplication even. Like
If you go back to one of our previous API reviews, find the diagram that I shared of it.
Something somewhere is a times. Presumably that means if right has like bit right 1 and 3 times plus times 8. It makes stuff happen. It like big multiple. how is
Bitwise means and, or, and only thing I can do with bits.
That question, the second class is not add ARM16.
No, these are that they are only available with the crypto APIs that we've so that the long overlays are explicitly dependent on AES.
These are all top level types in the ARM namespace.
Yes.
Taking what dancing it. I mean, assuming it makes sense to people, but that's a big caveat for all of these APIs. Right. So, ready? That outcome. Man, if you keep this velocity going, I might actually go through all 10 of them. I can't believe I'm saying this.
Alright, so these are round to integer intrinsics. They don't. So rounding is which are a couple issues down. Rounding takes a float, truncates or converts it to, but keeps the result as a. Whereas convert will actually. That's basically there. So these are the round ones. They take a float, they return a float, but dropping fractional in some fashion. First two here are ceiling and floor. They are largely APIs. We exposed similar for x86 because they existed in the native interest. They're essentially for round 2 positive and round 2 negative. And then for the group after that, we have similar set of 5 APIs for rounding mode. So there's away from 0, nearest, negative infinity, 2 positive infinity, and 2 0. These are using the same naming terms that we use midpoint rounding, the general math enumeration, and also math for x86 and elsewhere. They largely come from the IEEE spec. There are sometimes they're called minus infinity rather than negative, and sometimes it's called ties to 0. There's also the current direction. We exposed the same API on x86, but there is no current way on .NET, no supported actually rounding direction today, so it isn't strictly. And then there's also a variant, frent x, which does round current rounding mode, but it will throw an exception if the if the output can't be exactly represented. We do not support floating point exceptions at all in .NET, and we've got no equivalent anywhere else, so it's not proposed.
current direction?
Whatever the current rounding mode set for the hardware on that core.
You have that mode exposed?
Not currently doing it. We exposed the same API, x86 though, which is exposed here. In .NET, normal operating mode, it will be the same as to nearest.
Why would I want to use an over specifying what? Depending on ambient state, seems like a problematic idea.
It's a functionality required by the IEEE spec and so hardware.
Right, but why would anyone?
Not on ARM is fixed with everything. Bytes.
So this instruction is just literally your.
It's used whatever the ambient state is.
Right. Same statement.
Basically it allows you to write a program that directly follows the IEEE guidelines affecting the existing rounding mode set by the environment.
I mean, I guess.
So if you're in a program where it knows that it tries to be incorrect due to the inputs being given, they can set the general environment state in a math dot cosine function that now works correctly under that new state.
It possibly make level of set a thing, and then for the rest of this, the fact that it is a contaminated state, back state. Question. I don't work in silicon.
It effectively write a generic algorithm that supports all rounding modes without having to go and provide 5, 6 overloads of the method for explicit rounding mode.
So maybe I missed this, but are we doing this for other? Is ARM the only one where we exposed this? I can't remember having a current one for any other.
We have it on x86. If we hadn't exposed it on x86, we shouldn't expose it for ARM until we add support it to actually not crash if you're rounding mode.
I mean, do we like? Okay, we exposed it on x86, but like, I mean, do we know anybody's using this? Like, do we consider this a mistake, or do we consider this that we did it and it's fine? That's the thing I'm not.
It's something that has no use if we ever support rounding modes and there are proposals, right? Then it's something that we would eventually need to propose.
I mean, I'm fine
with
rounding mode.
It is, but the runtime does not play with that. You can get into various bad states and fast the run.
But that sounds like it's not.
I would say it's further beyond just ensuring it doesn't crash. I mean, but there really isn't a programming model currently for how you utilize this of floating point hardware. So it's something that we would clearly define and articulate.
There'd likely be a lot of work in the optimization layer, in CSE, and everywhere else to account for what the rounding mode is, things like that.
But it sounds like something that is a non-trivial work item. It's not like we are on the verge of shipping this.
Right. But I don't know if LLVM example has mono on LL restriction or Unity's burst. So there's theoretically no harm in us doing it from x80 or from runtime, allowing people to write correctly up with that support eventually comes in. or if a given variant of the
I mean, you can correct me, but like I'm skeptical that somebody can write correct code when they're not able to really execute it. Like it seems a bit like cart before the horse kind of moment. I mean, like with .NET Standard, I would kind of understand why we would expose it earlier because then it's hard to ref later. But in the context of core, it seems like once the feature is there, it's trivial for us to expose like 10 more overloads. Like I would generally prefer if we would expose features basically when they're ready and not like part of the feature now and then before you can actually use the feature later, right? It seems like kind of a problematic approach.
I'm fine with that as well.
And so which one would this would just be the current direction one? You have two nearest near. And earlier you said that you have some other overloads that return ins, but they are probably in a different issue, I suppose. Right?
Yeah, they're down where it says arm convert something.
How do we call them? I guess what I'm curious is like how do you make sure that when people call it that the method name is indicative whether you get back a double or basically truncated.
We have round and in 32.
I see. Okay, yeah, that doesn't get much more descriptive than that.
Which matches general naming that elsewhere, like on the math class or physics, and the terms that the hardware uses.
Anybody else? Anything to talk about or?
I passed this step already. Sorry if we did, but I did agree with the points that you were making that we shouldn't expose intrinsics. People can't actually use it.
Well, to clarify, they can use. They just can't change. It's not like we can test that the instruction omits right encode. But we know that we can omit right encode and everything else.
Yeah, but I guess
You
the
could
question
imagine
is there
using
something?
this. You could imagine using it in a super paranoid way to say, check the current direction of running and make sure it's correct. Can't do anything. Not, I decide well I'm gonna fail, but
Yeah,
it just seems like if I were to use it, I would probably have to test it in both modes, right? And then it seems like that is something I can't easily do today, right? I can only test it in one mode with, that's basically that say the runtime is in, right? Runtime works in one mode, and if you change it to a different mode, the runtime doesn't detect it very well. So I would assume that customer code wouldn't be any different from that.
Well, the core CLR acts that way. We would have to talk to someone from if Mono LLV has the same. They support a number of things we don't, and vice versa.
Oh, I see now what you mean by LLVM. That makes sense. I mean, yeah, I mean, like, don't get me wrong. Like, if you have it implemented in one runtime, like, that seems good enough for me. Like, it just seems problematic to say you don't have the feature implemented like end to end in any runtime. It's just basically we are preempting the API because we do it later. That seems problematic because in my experience, changing APIs is almost the hardest thing we can do because it's very customer visible, and until you actually have the feature, you're saying okay, we know what the encoding is, so it will be trivial, and you're probably right with this, but it just seems always kind of problematic to do the second step before the first. And it does. I don't see any downsides with doing it. I guess that's why I'm just leaning towards let's just do it when we actually do the rest of the feature work. But if the mono guys say, oh, we want to have this, I would not be opposed to adding this API.
All right. So maybe we everything except for current direction, and then I have a follow-up item to talk to Mono, see if they support this, and if they do, then it is tentatively approved. Assuming no one has an issue with the name, and if not, then we just close it until some runtime does.
Yeah, yeah.
Okay with that.
I'd be shocked if they cared, but have it on the right. I have like 20 tabs open. Right, so there's that.
So these ones are load and insert. They load a scalar value from the given address, insert it in value at the specified. So it's essentially load, or it's basically insert, but with it explicitly coming from memory, rather than say a general purpose register or a selected in other vector. The ordering parameters here matches C++ intrinsic. I called out at the very bottom, we might want to consider ordering it value index address instead, as that matches the assembly instruction takes, and the order used by the other instructions.
What are we doing for other instructions? We generally follow the instruction, not the
Right. Well, most of the time they lie. This is a don't. But we've previously tried to order in relation to instruction. It will be a point of confusion, regardless, choose for some users.
I mean, the general rule of thumb was we want to expose the intrinsics as they are represented by the hardware manufacturer, right? And then it's also why we have the name of the intrinsics and whatever link we have for the document. It would make sense to me to match the. But I agree with you, like if you, depending on what code you're porting.
Having it.
There's no confusion. Types are all.
Yeah, I was about to say, like, if the types are, like, if it doesn't compile, it's fine, probably, because you would.
Right. The confusion comes from they might expect copy the API to largely for the parameters, but for these ones, they have to swap the order. It just makes porting harder.
I'm confused. If they're porting from C++, parameter orders already correct.
Right, but I had called at the bottom. I want to value and address instead to match the ordering of the insert intrinsics that take it by value, and to match the ordering that the instruction takes, as the instruction takes value in address.
Sense to me. Notation is a bit off.
This is basically the same API, but rather than. And same thing, the C++ intrinsic takes address value index, but the instruction takes value index. should basically mirror copies, but void return rather than vector returning, since it's a store.
Um, it's like a no-brainer then.
Yep.
This is basically equivalent to round API, but rather than returning a float, they return integral. So convert to int32 and convert to 4, and then rather than just doing away from 0 and to negative infinity, because convert to int32 negative infinity thing, I pre-round. So convert to int32 round away from 0 and convert to int30 round to negative, etc.
So since my mental mapping capabilities are not that sophisticated, is this literally the same thing as before, just with convert to int32, basically? Are there any other difference?
It's basically the same. There's a couple of very bottom that do the reverse. That is integral floating point types. And those are called convert to double, convert to.
Try to align this. Um,
I'm just curious, in the framework, do we have any guys that include types like uint32, uint64 in their names?
all the
Yes.
time.
Okay.
It's
The conventions to match the framework name rather than language name.
Right.
and the most popular one is convert to in64. Like they're just usually method calls, right? It's like there's a static convert class. Takes object and then
It's called convert to int32 and so forth without the rounding.
no, there's a method called toIn32 on a static class called convert. That's usually the pattern, right? But like the usually on an object you would have a toXXX.
Yeah, but you have any other or flash vector that are convert to int32? Or are those passed?
These are the APIs that do.
Okay, So these are all new.
They're basically not cast, right?
Right. The reinterpret guys are called as, and their general purpose ARM or x86.
I think they all make sense to
I mean, the question is, does convert bias match, right? Because usually in the framework we just call things two, and then the fact that it's two implies it's a conversion.
Well, we have like convert dot to, but in this case, part of this MD class. So
yeah, for convert that's true, but I mean, convert really the only thing that this type does is is the actual conversion, right? Usually you have a type, and let's say, like for example, on array, you have on enumerable, you have an extension method called toList of t, right, or to a, right?
But when to is the verb, always applying on an it's just a static, so having to convert is like convert's simply an implied verb.
I guess that's fair, right? Because
We also use convert for x86, and it's the name that the underlying instruction has.
yeah, that's all.
The one thing of note for convert from integer to floating point is there are 4 variants deal with what the ARM architecture manual fixed point, which seems to be ARM32 specific, and I finished being able to understand how it worked, and those are right now. From what I can tell, guys effectively take a int32, for example, and then they encode in the immediate where the decimal point lies in that int, and they use it in the form of basically compressed encoding.
I mean, it seems unusual, but also not. For all of the missing the word here. But like you get the point.
It require I figured it a bit more I thought and process in determining how it works, therefore how it should be.
I mean, the most obvious thing I can think of is you make it a parameter. Then you have the same problems that you have with all of these guys, but probably be sensible. I mean, you could also, I mean, given that, I mean, I guess for 64-bit that would be ridiculous, but for 32-bit, having actually 32 overloads might also not. But that's shitty to call.
That.
Well, it's shitty when you have to actually have it as a parameter, right? Because then you have to write the switch statement yourself. But yeah, I think parameter would be fine. Most obvious. Deal with the fallout. Anything else, or is that it?
That's it.
Was done beautifying it. Right. So basically. I really wish there was the thing in the idea.
This is just a mix of miscellaneous APIs that were missed, not covered. Other proposals done up.
Like the remaining hour then?
No, this is simpler. Next one has some crazy names.
Next one will take. A moment I thought we might be able to actually finish and the background.
So the first group here is just variants of absolute, which we call just ABS, matching the name, but it saturates the result, and rather than returning unsigned result, saturated sign.
Right.
So if you trying to call it on short dot min, for example, back short dot. I think you get back short dot. Do the saturation.
Do we usually use just saturated, or didn't we say and saturated? I don't
Nope.
know.
This is the case where on x86, just the term saturate, not saturating anything. And we've carried that over to ARM. So
Okay. I have literally no idea how you can remember all of this, but I guess somebody had to type all of this.
then the next group is convert APIs. They're basically similar to convert APIs we just, except they convert from float to double and double to. So they're essentially widening in versions here. For float to double, it is a widening conversion, and so there's lower and up operating on the respective halves. And since there's no vector 256, it just returns vector 1.
Isn't convert to double lower except vector 64?
That's not how the under exposed. We could expose we could expose just a convert to double that took it float. So
Because it looks like the L instruction has arrangement to S, plus it would be to float.
no, because there's only one. If you look at the combination, then win size the only the oh, I guess it does. It should support A. So there should be another variant then that convert to double that takes a vector 6
and then return.
and returns a vector 1.
So that means both of them just get an over.
No, just the. And I wouldn't want to for a postfix. That would imply you're only reading lower 32 element.
Okay. would be convert
So
to double x vector 64.
and
Translate that
returns 128.
same is then also true for single. I think
Yeah. With single narrowing, so alt half the way. It pattern taking vector 6 in the second version.
I guess we always use upper suffix for long iteration. You use it too?
Well,
Consistent. Like, for example, polynomial multiply just proved widening. We also named lower and upper how we encode that rate on first or second half of first register. We do the same for convert to double, keep lower and upper side. We would know that we operate on vector 64 or upper part.
that's what's there.
Yeah, because I thought suggested to drop
No,
lower.
no. For the variant that takes a vector 6, we can't use because
Can't.
because that would imply we'd be one float rather than higher vector. So we'd have convert to double vector 64 float, and then convert to double low vector 128.
I remember cases where we operating on all vector 64 source, but also named method lower. So this is how we encoded the upper rate on vector 128, but only read upper half. Yeah, there is a multiply widening rate on vector 64 of int for return vector 128 too long. There is also by widening upper will operate on vector 128 vectors. You'll only read highest halves.
I guess that's a general naming, because also it's not that the lower half. I don't think that one where the half of the involved. It's returning the lower one. It's a vector 50 that would end up being.
Because sometimes mixing long, widen, long construction basically operates on either first or second half of, and there's a widening return is upper lowest part nation register. For both cases, lower and upper. Guess we can follow up later. might be clearer to there, like keep lower or drop it. This for now we can go without all.
Of that vector, so it doesn't seem correct to me.
Yeah, that's my general.
But I thought we were using scalar by the first lane.
Well,
Check.
scalar means we're only the 0th element.
Yeah,
Which, if we're taking a vector same as,
right.
but we're not taking. The result is always a vector 128. So you're taking for the variant that taking both floats and converting it to two
Double.
doubles in a vector
Right.
1. Whereas with the convert to double lower version, taking in 4 float, only taking the lower 2 and convert to 28. And with upper, you take upper 2 of the vector, separate vector 1.
But do we actually need to convert to double lower rates on vector 128 float? Because you can get lower
Well, that
effectively at the lowest half.
could do that with a guys. We had previously said we would be explicit to avoid people needing to insert the get lower 2 vector 128 unsafe APIs.
Because it looks to me that we broke this rule times already by not exploiting such forms differently.
If there's ones that are missing, we should probably collect a list of those so that we can follow up and make sure they are consistent.
Yeah, I guess it's pull out. Make sure that it's exactly the same.
Yeah, I mean, that
I'm
would be
sure.
desired. I mean, it's normally I would say the value of the API review is for us to actually check for that. The problem here is that there are so many names that unless you're domain expert, you are very unlikely to find these.
Yeah, there's 2,000, close to 2,000 APIs total. So I'm sure we've made some minor mistakes that we've caught and we fixed. Entirely plausible that there'll be some that won't be
miss.
caught until customers are using it, and probably a couple that we're shipping with by accident. Realistically speaking.
Yeah, and honestly, this is also the area where I'm somewhat fine with that. Like, it's never great, but it's also not terrible. So then which ones are we following up? Is it just the lower thing?
Yeah, it's the usage of lower and upper. And if there's any places where the instruction can take a 28 and we've only exposed one version, requiring users to casts.
I don't see a version that take 4 floats. Like, what instruction other than convert to double upper L2? But convert to double lower yes, both, right? Not sure why we need load lower version.
There's a native API that
You mean like C++?
Oh, nope. It's just the one that returns high that takes 128.
How called? Yes. Yes. There are so many of them. Yeah,
One?
there is one that plot by turn 64 by 2.
And the other takes 32, but it's labeled high.
Yeah, it's a bit lower upper. There is also one that is plot 6 for supporting. So yeah, I don't see one that takes 32 by 4 high.
Okay, in that case, we have one that's not named.
So the proposal is to get rid of vector 128 lower and have a vector 64 version.
Without the lower.
And there is another way, implicit or explicit, to convert from vector 1.
Yeah, you have to do dot get. It's an extension method.
I've heard several times try to be very explicit about allowing people to express exactly rather than hoping that the optimizer does it for them.
Right.
Does that fit with that logic?
In the case of get lower, it's a no op unless the register allocated, either because it needs it because the some other scenario. But vector 64 and vector 128 on ARM64 represent the same underlying the 120 instead of the 60. And so it's possible to take a vector surface and code it correctly. So then it just becomes a question of, do we want to expose a variant that takes vector 128 as well as the vector 60, or just match what the underlying instruction actually and only take vector 60?
According just what actual instruction supports.
I agree. Because otherwise, because many more overloads other than I
So
have
then,
another question. Could it be named convert to hybrid? At some point, status of plot 16, then we can just reuse the name, use a vector 64 of or type name.
that doesn't match with how we've convert APIs, where the name of the type is to for clarity. So I would say we would just expose to single that takes a need of half it.
we move on?
I think that's everyone. But that's only, there's more APIs in the. I just meant we were to. The next ones in the list are extract, narrowing, lower, saturate, signed, extract, narrowing, upper, saturating, and then extract, narrow, lower, saturate, the upper variable. The signed versions support, they always returned a signed result, but they support being signed or unsigned, whereas the unsigned variant always return unsigned taking.
Shouldn't the upper and last?
I put it not as the last because the order of operation is extracts, arrows, the upper or high half, and saturate. And sign didn't fit anywhere else. Maybe after.
Well, I guess
extract.
narrowing is upper will result in upper half of the lower first and lower part. Zero the upper part, right?
Right.
In this case, instead of storing in the upper half, this is extracting the upper half.
It extracts.
Well, don't think it extracts from upper half. Extracts whole vector. Like it's narrow whole vector, different algorithm, create to unsigned or signed value. Store it to either lower nation. That's why we need and upper version.
It reads each vector element, saturates the value to half the original vector, writing to the
Kind of suggest lower and upper.
So extract, narrowing, saturate, extract, narrow, saturate.
Upper.
So that's taking the existing name and just putting upper and lower to the end.
I was just responding to somebody's tweet. What was the conclusion here?
Take the upper and lower keyword that's in the middle of the API and move it to the very end.
Basically, they extract narrowing, saturated signed. Yeah. I guess. And narrowing. people how people live without multi-carat edit. Okay, so the only usage and sim.
So what is saturated sign? Like it looks like there is a version, like there is an interaction again that does saturating.
Yeah, the
That
UQ
does unsigned.
right. So the SQXN takes signed. There's X XT takes unsigned signed, and
I
then
guess it's the
there's
other way around.
no that one that, and then there's XTN which takes unsigned, turns unsigned. There isn't a variant that takes
Well,
or that takes signed.
SQXTUN sign integer value trades value to sign integer sign unsigned. The shifting construction of similar concept. Basically, there is a sign, unsigned, signed, unsigned.
Okay, then I just got the return.
It looks like we need extract narrowing over saturate, extract narrowing or saturate unsigned. First one should iterate on both types, which correspond to iterated value. Iterate on unsigned, it will return unsigned max value, or signed max value. Let's operate on signed, it will signed max. Saturate unsigned, that is return corresponding unsigned max value, which is
Right, so just the APIs that take in return signed should be under the second group.
yeah, but I don't think we need explicitly traffic to them with signed.
We do because you've got variants take signed and return unsigned.
Yeah,
and you can't
for those
overload
that
on
take
return
signed and return unsigned, with unsigned suffix. Those that take signed return, unsigned return, unsigned, don't add any suffixes. Narrowing such.
I think then it's just makes it clearer if you have
Yeah, for consistency thing, is for shifting intrinsics whenever you use signed, probably do it here. We only used unsigned.
we postfix with both arithmetic and logic.
Postfix with logical arithmetic. This is because we decided want signed overload gave us logical right shift. Tracking different.
Well, the saturation is
Yeah, it will be clear from line type and value, except with unsigned where you can't by the source type. You have to say that I'm going to saturate to unsigned. So basically, SXTN and 2QXTN not have any suffix as how we're going to only SQXTUN have signed suffix. But the turning value -1 saturated.
well that would be signed
you extend un, there's unsigned.
Right, and I think this entire confusion by just having the suffix in general is better, because then it just tells you returning unsigned or signed. You don't have to look at the type. You don't have to guess what hover over types. You see that it's unsigned and it returns unsigned, and it's signed and it returns signed.
But I guess if you follow this rule, then we need suffix gate or apps suffix rating.
Yeah, potentially. Although negate is signed. Just absolute signed. So maybe we should just mark the extract narrowing. We should come back after we it and how to separate signed versus unsigned, unless someone wants to provide input.
I guess it's other.
Did I miss some conclusion right now?
It sounds like us the extract narrowing and bring that.
So that means I would just remove the extract narrowing one, both the lower and the upper.
Mm-hmm.
And that includes the saturated one as well, right?
There's only saturated.
Oh yeah. I don't know.
And then following that, then negate saturate, which is just negate, but it returns a saturated result to account for. And then for underarm 6, ab saturate and saturate variants that take long.
How negation saturation works? Suppose I have byte 120 and if I negate this, it's gonna saturate. Result unsigned, right?
No, it explicitly returns a signed result, what the API says.
And it will return 120.
The API does a
Okay.
it returns either end up returning either int dot max value, dot min. I'm not sure which.
I see. That's signed. Will return 120. or my
And then there's add across widening, which just adds across. Returns. I think I messed up. Return type. The return type should be twice the parameter.
human element type, right?
Yeah.
Vector
So,
or, but I guess
so
the stuff should return also.
no, these are slightly different from the pairwise. They widen. I don't believe we have add pairwise. No, we do. So for the long, yeah, for the U long, it would be the same as pairwise function. And it's because that overload shouldn't.
And same for long, too long
Yeah.
and long.
So Imo, it's where it says byte for the return type, that should be short, and where it says short, that should be int, and int should be long.
And the vector size should be vector 64 for it.
Yeah, that's
It's sort of the vector size. The vector size should be 128. Is that what?
no, the
No,
return the return type should always be.
We talk about negate saturated, right?
Oh, it's at the cross widening.
Here you go. So here. And then you said the byte is going to be too short.
Almost done. That works.
So what Jeremy is eating, but no, I'm getting hungry myself.
There it is in chat. So it's the same API basic return types are vector 64, and the element type that's twice the size input. So byte becomes short, short becomes int becomes long, s byte becomes short.
All right. So, oh, once. All right.
And then the next two are similar. So there's U squad and and U quad takes in a left parameter in the destination signed. Right parameter is signed of the skim width. And then U squad is the left and for unsigned, right signed. And then the
This one and before.
Ever based on the first
the result is the same as the first parameter type, but the right is fine. And then the very last guys are invert to single uh, from double, but they round rather than round to just
elsewhere you explicitly called out signed or unsigned. That
for which ones?
for the add saturate.
No, because the result there's no ambiguity inputs result. So far, the only place maybe needed signed or unsigned extract narrowing, because there are some overlaps that conflict and so you have to differentiate some. But Igor and I are going to discuss that offline to determine whether the suffix and post should be used all of those only on variants that are unique.
I'm trying to think of if there are potential errors that calls add just accident swap left and right values and get a different return type.
Unless they're using var, the compiler error in that. But I think this is also along the lines of thing earlier, which there's other overloads like abs, which take signed and return unsigned, versus abs saturate, take signed and return signed, where you might have
Yeah, to me, it's kind of a war. You make some things easier, you make other things harder, but
Yeah, they seem fine to me.
I feel like if you want to be explicit with these APIs, then eventually, like, every single intrinsic becomes a paragraph. We are already halfway there anyway, but like sometimes I feel like maybe it doesn't.
Yeah, there's a lot more gotchas beyond just the name. I'd hope anyone using already advanced API is correctly testing and profiling their hopefully catch issues.
What you're saying, we should suffix all APIs with and be careful.
Unsafe.
That's an uplift. In the round over.
So it's the same as convert to single at the top, but the rounding, which basically have a result that is exactly halfway represent results. It will choose the odd result rather than
May have made my life hard again. I think my notes tool only picks up comments that are close to a change within 10 minutes or so. I posted 26. Can't win here. Does this capture everything we said though?
it,
Did some edits here as well, but
the convert to double up. We said
those guys.
no. We just said that there was 128 version. The convert to double lower 128 shouldn't.
So the other one is just a replacement. That did not. Right. Happy with that?
And then we've got one. The other one I just looked at is actually not doing 5.
Yeah, I can.
Yeah, because that's one that it basically couples of elements.
Jeez.
So it will 2, 3, or 4 vectors that live in continuous register.
No, it's not about this. For player, for arbitrary register, doesn't have to operate on continuous register.
Ah, okay. The one that does different one then.
Yeah, it's the one that we have verification how the continuous register is exposed in the framework. Start working on our side. But for store pair, there any blocks us right now.
Okay. Then we've got 2.
And there is a float pair I have proposed here because I wasn't sure, like, if you want to see apples, one value needs to be stored actually.
What what I'm hearing is that there's one more meeting,
Yeah, it sounds
least.
like.
and maybe we get away with one.
It sounds like we just have a hair version, maybe this, and the feedback that we got from this meeting.
Yeah, and we probably should do some survey. So there are many proposals how we should continuous register actions. One of them is tuple, other is special structure, sector 122 at 3x4. Just we need to survey them all, compile them in one issue, just look at one.
Sounds like one more meeting should be.
Yeah, so calendar-wise, so Thursday we will look at HTTP again. I should say system net connections. And something tells me that we probably also need one more for that one, probably. And then Friday is off. So next Tuesday we can then decide whether we do either follow up to the system net connections one or the ARM.
I think Igor and I could probably resolve the remaining questions about the APIs by if Igor thinks so as well.
Keep in mind
Yeah,
Friday is
we
off there.
can do it via email. Sharing.
Yeah, it works. I mean, just let me know.
And
I mean, we can decide late minute. Like it doesn't be. You just have the slot, and then we will always fill it with something. I mean, worst case, we review the backlog. Never happened.
I never really see Germans with comedy.
Oh,
Thanks for breaking stereotypes.
what can I say?
well,
Too long in the US now.
For this one in particular, there was a question of basically for the APIs here. Name, I think fits. Should we? I don't know where we should put by select scalar keyword in that group. If anyone has last 4 minutes.
If there are strong opinions, you should put it in the right spot.
Great. Where is the right spot?
It's for you to figure out, Tanner.
Shouldn't be multiplied up because we had having additional keyword after.
I think the difference in the. Nope, never mind. Yeah, I multiply doubling. And I can fix that, but that's still necessary to clarify where to by select scalar.
I think right after that makes sense. By doubling by select scalar.
Saturate.
Yeah.
Saturate I.
Isn't that what we just did? We just by selected scalar also.
Oh, sorry. I know. It's a. So we've got the doubling multiply doubling by selected rate high. These are scalar by scalar. Scalar by selected.
Huh.
So it multiplies left 0 by right in.
Oh, yeah.
And so when you have both scalar and by scalar.
Well, it should be multiplied scalar. No?
Yeah, the one downside is scalar suffix else. But maybe that's not too bad. Seven method group. Then I will, this proposal, we can mark store pair as ready for get up the load pair with the meta part about how to return and take multiple vectors, and then
There is one more item. Amar post. Dot product operation recorded in ARM 8. Probably should pull up with ARM. And then we should do it ourselves.
yeah, I think what we said was it on the general backlog, and the goal for get advanced SIMD and what support an 8 out. And then anything else is icing on. We got all the desired stuff done, and we were
The meeting, guys.
Is Tamar invited on last time?
I believe the invite normally been on them before, but he's also in London, so I'm not sure what time it is for him.
PM. Currently.
Be good for the day then.
I think that's everything.
For the rest of the week. Watch the build stuff. And answer
Thank you.
questions on social media.